Welcome to 4.1's video. Our lesson essential question is, can I identify the names and relationships of the angles formed by a transversal intersecting parallel lines? And can I identify circle vocabulary? So in class, we had done an experiment, an investigation, where we learned about some of the different types of relationships or names of these angles. So parallel lines cut by a transversal. So these two lines are going to be the parallel lines, and the transversal is going to be this line. And to take a minute, these two are going to be my angles that are linear pair, and they will add up to 180. The first type of angles would be my same side interior. So this is the interior of my two parallel lines, and then this would be my exterior here. So same side interior angles would be on the same side of the transversal. So these two would also be another form of same side interior. And the relationship between these two same side interiors, they'll always add up to 180 degrees. Alternate interior are going to be my alternate side, but interior. So here we have 3. The alternate interior would be A, or 6, and then the alternate to 4 would be 5. And these angles are going to be the same, so they'll be congruent. There's another one called alternate exterior, and these are going to be on the outside, but alternate sides. So here's an example of these two being congruent, and then the opposite side, those two being congruent. And we also have corresponding angles. So corresponding are ones where one is on the interior and one is on the exterior, but they're on the same side. So this angle can slide down the transversal and it will match up with this angle. So there are 4 corresponding angles per linear or per parallel lines with a transversal, and corresponding angles are equal. We also can have vertical angles, but this one doesn't relate to it being parallel lines. It's a great review. Vertical angles are when you have an X and the two opposite angles are going to be equal. Moving on to some circle stuff. So 2 points on a circle determine a major arc and a minor arc. So here's my circle. My 2 points will be A and B for this demonstration. With the arc with the greater measure, which would be the one from A to C to B, is the major arc. So this one's the major. And then the other arc is going to be the minor arc. So major arcs are also going to be greater than 180 degrees when I look at the angle measure inside. And that means minor arcs will be less than 180 degrees. A secant of a circle is a line that intersects the circle at 2 points. A chord is the segment whose endpoints are on a circle. So the secant is CD, the line that goes through it. And the chord is only this part inside the circle. Now we're going to learn about inscribed angles. So an inscribed angle is the angle whose vertex is on a circle and whose side contains chords of the circle. Angle PMD, so let's find that, P to M to D. This angle is inscribed. The vertex is on the outside, and I can see that there are 2 chords that are there. The intercepted arc is the part of the circle that lies in the interior of the angle, with the endpoints that are the intersection of the sides of the angle and the circle. So the intercepted arc is going to be this part along the outside of the circle. So intercepted angle makes the intercepted arc. So can we compare the measures of POD? So let's measure that, P to O to D, and PMD. So those are those 2. So we can figure out what POD is. That's going to be 90 degrees. And I know that because this is a linear pair. These two angles add up to 180, and I know that this angle is 90. And then for the other angle, and let me erase this, the other angle in question is PMD. So if I look at this triangle here, well, this is a 90-degree angle, and this is a radius, and this is a radius. So that means this is an isosceles triangle. So if it's 180 degrees minus the 90, so then I have 90 divided by 2 angles, gives me 45 degrees. So if I look at the relationship between these two angles, they have the same outer arc, PD, but DOP is on the center and PMD is a inscribed. So I can say that I know that if arcs or angles that have the same arc, one's central, one's inscribed, the inscribed angle will be half the measure as the central angle. I'm going to type that out for you. So this is something that you guys should definitely write down. Okay, next thing, consider the measures of the inscribed angle that intercept the same arc. What conjecture can you make about the relationship? So let's make some lines here. So I'm going to say I have W, X, Y, and then I'm going to have Y, W, Z, W, Z, Y. So they intercept the same arc of Y, W. What can I say about the same angles? Well, let's check this. I'm going to take these two, and I'm going to group them together. And then I'm going to take this, and I can move it. And if I move it, I'll move it a little too far. That is the same angle. You just can't move it over enough to line it up. There we go. It's the same angle. So what can I state? I can say that inscribed angles that have the same arc will be congruent. And that is also something that you should write down. Next thing is a circumscribed circle. So it has two sides tangent to a circle. A circumscribed angle. So here is a tangent line, and the definition of a tangent line is a tangent to a circle is a line that intercepts a circle at exactly one point. So if we think of a chord, which we learned about earlier today, a chord is a line that intercepts at 2 points, and a tangent would intercept at only 1 point. And that point is a 90-degree angle with the center radius. So that's going to be so I always know that's a 90-degree angle. So an inscribed angle is going to be an angle that has a circle in it that has two tangents. It's going to be formed by two tangent lines. Okay, so to review our lesson essential question, can I identify names and relationships of the angles formed by a transversal intercepting parallel lines? That was the first part of this presentation that we did in class. And the new stuff was, can I identify circle vocabulary? That's going to be my inscribed angle, my central angle, my tangent line, my inscribed, circumscribed angle, all that stuff. So, good luck with your Mathia and Delta Math.